Welcome to the 8th lecture of this course. Today we will discuss another way of representing languages, namely that of regular expressions. So, regular expressions are an algebraic way to represent languages, and as we shall see that the class of languages that can be expressed via regular expressions are exactly those are exactly the class of regular languages. Okay, so that gives the name regular expressions. So let's so before I formally define what is a regular expression, we will try to understand what kind of strings are accepted by regular expression. We will look at some examples and then we will look at the formal definition. So as I said, regular expressions are an algebraic representation of languages, and in the real world, in practical cases, so they have many applications. So they have applications in your favorite text editor. For example, if you are using a text editor like Word or any other text editor, and you want to search for a word. Okay. So the way the word application or the software goes about searching for a word in your document is basically by using regular expression. Okay. So if you want to search for a word, it tries to match whatever word that you are searching for in your entire document, and if it finds instances of that particular string that you are searching for, it will immediately tell you how many such instances are there and where they are present. Okay. So that is one application. So in text editor to find strings. Also another example is in compiler design. Okay. So for example, when you write a C program, okay, so when you write a C program, we put comments in our C program, and we know that comments are basically pieces of text which are not necessary to compile the program. They are not directly useful in compiling and executing your program, but they are there basically to help the user understand what the program is doing. So how does the C compiler know which part of the text is a comment, and how does it remove the comment from the main program during compilation? So again there basically what is used is regular expressions. So recall that in C program, one way of putting comment is by giving the slash star string, right. So if you write anything between a slash, a front slash star and a star front slash, that is treated as a comment. So what your compiler does is, before it compiles your program, it searches your entire program. Again, it does sort of a string matching, and it tries to find occurrences of front slash star and star front slash, and then whenever it finds such a pair, it just removes everything that is there between it. Okay. And it does this for every such pairing of front slash star and star front slash. So this is how comments are eradicated. So these are two very common examples of regular expressions. There are other places also in which regular expressions are used, but for this course we will not be interested in the application side. We will try to see what what is the power of these expressions, in the sense that how are they, I mean how do regular expressions define languages, and what are these class of languages. I mean we will prove that they are actually exactly equal to the class of regular languages, which shows that anything that can be accepted by a DFA or an NFA does have a regular expression for it, and vice versa. So, before again I look at the formal definition, let us look at some examples of regular expression. Okay. So let us look at some regular expressions and their corresponding languages. So, if I take the regular expression, let us say 0. So, this is basically just the language consisting of the singleton string 0. Similarly, if we have the regular expression maybe epsilon, so this is again the language consisting of the singleton string, the empty string or epsilon. The regular expression 0 union 0 1. Okay, so union is a symbol that are used in regular expressions. So this consists of so this is the language consisting of the strings 0 and 0 1. Okay. Another way of writing regular expression is using the star operator. So 1 star corresponds to the language which is basically consist of all strings which have k occurrences of 1s, where k is greater than or equal to 0. So, if it is 0 occurrence, that gives the string epsilon. For a single occurrence, we have 1, then 1 1, then 1 1 1, and so on. So, it is an infinite language. And let us look at one more example. If we have a regular expression of the form, let us say 0 union 0 1 concatenated with 1 star, it basically consists of all strings that I can form by first taking either 0 or 0 1 and taking a string from 1 star and concatenating them, and I just write out all those strings. So, basically first I will have 0 concatenated with epsilon, that will give me the string 0. Then I will have 0 1 concatenated with epsilon, that will give me the string 0 1. Then I will have 0 concatenated with 1, that will give me the string. So, 0 concatenated with 1 is again 0 1. So, I do not write it again. Then I will have 0 1 concatenated with 1, that will give me the string 0 1 1. Next I have 0 concatenated with 1 1, which again gives me the string 0 1 1, which I do not write. Then I will have 0 1 concatenated with 1 1, which will give me 0 1 1, 0 1 1 1, 3 ones, and so on. Okay. So, this is these are the ways in which we can form languages out of regular expression, and observe that a regular expression is just a finite expression, in the sense that it consists of a finite number of symbols, okay, but it is capable of generating even infinite languages. Okay. So, now let us look at the formal definition of a regular expression. So, the way a regular expression is defined is in an inductive manner. Okay. So, we will have some base cases, some base regular expressions, and then we will form regular expressions inductively using these base cases. So, R is said to be a regular expression. In short, we write it as RE. Okay. If R has one of the following forms. Okay, so if it has one of the following 7 forms that I am going to describe here. So the first is, it is so again I am going to describe it as I said inductively. So let me write it here. Regular expression the corresponding language, and just let me keep this for comment. Okay. So if the regular expression is phi, so that corresponds to the empty language, the language which does not contain any string. If the regular expression, so this is the first one, if the regular expression is epsilon, this corresponds to the language that contains only epsilon. Okay, so an important point is that these two languages are different. So the first language is the empty set or the empty language which does not contain any string. The second language is the language which contains the empty string. So it is the language which contains a single string, the empty string epsilon. The third is a regular expression A, where A is any symbol in epsilon. So the corresponding language is the language which contains only one string, that is the symbol A, for every symbol A belonging to sigma. So these are the 3 base cases. Now we will have the inductive cases. Now for 2 regular expressions R1 and R2, R1 union R2 is a regular expression, and the corresponding language is L of R1 union with L of R2. We have R1 dot R2, which is L of R1 concatenated with L of R2. We have R1 star, which is basically L of R1 whole star. So these are the basic, these are the main 3 inductive cases. And the last one is just to introduce brackets. So we have R1 with round brackets around it. So this is nothing but same as the language L of R1. Okay. So what do we mean by L of R1? So basically this is the language of the regular expression R1, and same for L of R2. Okay. So to be more precise, let me write it here. So R is said to be a regular expression if R has one of the following from. So this language that I wrote here Okay, so let me just rewrite this. I will just give a name to this. So, this is my L of R. So, whatever regular expression R that we consider, this is the language L of R, and this is how it is defined. So, if you look at the example here, for example, when we have 0 union 0 1, this consists of the language which has the string 0 together with union with the language which has the string 0 1. So, 0 and 0 1. Okay. So, this is the formal definition. So, now let us look at some properties and conventions of regular expressions that we often use. So, the first one is similar to what we said in the context of automaton, that when we are given an automaton, there is a unique language that corresponds to that automaton, whether it is a deterministic automaton or a non-deterministic. The same thing is true for regular expression as well. So, for every regular expression R, there is a unique language L of R corresponding to it. Okay. But the converse need not be true. What do I mean by that? That if you fix a language, you can have many regular expressions for that language. In fact, you can even have exponentially many or infinitely many regular expressions for a given language. It just depends how you decide to form your regular expression. Okay. So often we replace union with the plus symbol and drop the dot symbol. Okay. So, just to give it a more algebraic feeling, when we are actually working with regular expressions, we replace the union symbol with the plus symbol, okay, and we wherever it is sufficiently clear, we do not use the dot symbol, we just ignore it. The next point is very important. This is regarding the precedence of the symbol. Again, like in algebra or arithmetic, when you are working with operators like plus, multiplication, division or other operators, and you form expressions using them, it is important that you have a precedence law. So, you know that which operation you need to perform first and which operation you need to perform after that. So, okay, so between any two operators you need a precedence. So, the same thing exists here as well. So, the precedence of the symbols, or maybe I should say the precedence of the operators from high to low is as follows. So, first we have the the bracket operator. So, whenever we have something in brackets, that needs to get executed first. Then we have the star operator, the star symbol. Then we have dot, and finally we have the union. Okay. So, star bracket star concatenation and then union. Okay. And the last point that I want to make here is what is the language corresponding to the regular expression phi star. Okay. So, this is a very important point. So, what is phi star? So, if you look at the definition, so when we have star of a regular expression, so this basically is all strings that I can form by taking 0 or more strings from the language L of R1. In this case, L of phi is phi. So, if I take 0 or more strings from L of phi, okay, so if I take 0 string, that basically gives me the, so that gives me only one string, which is the empty string, because the empty string is a string which has 0 symbols in it. Okay. So, that is the only string that can be formed by taking 0 star. So, the language of 0 star is the language which contains epsilon. So, it is not the empty language, it is just the language which has the string epsilon. So, this is very important, and this you should always keep in mind. Okay. So, now let us look at more examples. So, I will look at some more examples. So, we will have regular expressions on one side, and we will look at the corresponding language. So, the first one is let us say the regular expression 0 1. So, we saw something similar earlier. So, this basically is the language which has only one string 0 1. Next, let us take 0 1 plus 1. Okay. This has the strings 0 1 and the string 1. The third one is 0 1 plus epsilon concatenated with 1. So, how many strings are there in this language, and what are the strings? So, again first I take one string from this regular expression and one string from this regular expression, and I concatenate them. So, if I take 0 1 and if I take 1 here, so the concatenation of 0 1 and 1 gives me 0 1 1, and the concatenation of epsilon and 1 gives me 1. Okay. So, this is the language that is there, and these are the only two strings that are there in the language. The last example is the following. So, let us say we have a regular expression 0 plus 1 0 whole star concatenated with epsilon plus 1. Okay. So, what is the regular expression in this case? Let us try to form. So, once again we will take one string from the regular expression on the left hand side and one from the regular expression on the right hand side and concatenate them. So, if I take, so we have star here, so epsilon is a string. So, epsilon concatenated with epsilon gives me epsilon. Epsilon concatenated with 1 will give me 1. Next, if I take strings which have only one string from this set. So, if I take 0, 0 concatenated with epsilon gives me 0, 0 concatenated with 1 gives me 0 1. Similarly, if I take 1 0 from the left hand side, 1 0 concatenated with epsilon will give me just 1 0, and 1 0 concatenated with 1 will give me 1 0 1. Now, let us take two strings. So, how many ways can I form two strings from the left hand side? So, I can have 0 0. So, 0 0 will give me 0 0 and 0 0 1. I can have 0 1 0, that will give me 0 1 0 and 0 1 0 1. I can have 1 0 0, that will give me 1 0 0 and 1 0 0 1. And the fourth is I can have 1 0 1 0, which will give me 1 0 1 0 and 1 0 1 0 1, okay, and so on. I mean, now I will take 3 strings from this set, 4 strings and so on. Okay, so this is a infinite language, but basically the idea is that we, whatever regular expression that is given to us, we try to break it down into parts that we can solve in an easier way, or for which we can construct the language in an easier way, and then using whatever operators are there, whether it is a concatenation operator or union operator or star operator, we form the higher language that that is needed. Okay. So, now let us look at some examples from the other side, that is if we are given a language, how can we form a regular expression out of it. Okay. Okay. So, let us say we are given a language and we want to construct a regular expression out of it. How can we do that? So, let me define languages over here, and we will have the corresponding regular expressions on the right. Okay. So, let us say we have a language. So, all our languages will be strings over 0 1. So, suppose we have a language consisting of strings W, such that W has a single 1. Okay. What is the regular expression corresponding to this? Okay. So, if W has a single 1, the way to think how you will construct a regular expression out of this is, what will be the form of these strings? How will these strings look like? So, if W has a single 1, the string will basically be a sequence of zeros followed by the 1 and then followed by another sequence of zeros. And the sequence of 0 in the beginning and the sequence of 0 in the end can either be an empty, I mean 0 number of zeros, or they can be anything that is higher than that. So, the corresponding regular expression in this case will be 0 star, the first sequence of zeros, followed by a single 1, followed by 0 star. Okay. So, this is the language, this is the regular expression for this language. The next is, suppose we have, I just look at a generalized version of this language, or a slightly general version. So, W has at most a single 1. So, all those strings which have at most a single 1. What does that mean? That W can have either no ones or it has a single 1. If it has no ones, it basically means it is just a string of zeros, or it has a single 1, in which case we know that this is the regular expression. Okay. So, because we have this or that is separating the two cases, we write this as when W has no ones, it is basically consists only of zeros, or it has a single one, in which case the regular expression will be the following. Okay. The third is when W is a string such that length of W is divisible by 3. So, all strings whose length is divisible by 3. So, basically how do these strings look like? So, I will have a sequence of 3 symbols, then I have another sequence of 3 symbols, then I have another sequence of 3 symbols, and so on, and these symbols can be anything. So, the way to write them is, so the first sequence of 3 symbol can, so the first symbol can be anything between 0 or 1, the second symbol again can be anything between 0 or 1, and the third symbol is once again anything between 0 or 1. And this sequence keeps on repeating arbitrary number of times. Okay. So, I have a star around it. Okay. So, we have a sequence of 3 symbols followed by another sequence of 3 symbols, and so on for as many number as we want. So, now let us look at a slightly more complicated example. So, let us say all strings W such that W has a 1 at every odd position, and length of W is let us say length of W is odd. Okay. So, I want to look at all strings which have this form. So, how do we go about? So, it has 1 at every odd position and the length is odd. So, basically the first symbol is necessarily a 1 because it is an odd position, and then for every pair after that I can write the pair as the first symbol of that pair is a 0 or 1, and the second symbol is necessarily a 1, and this pattern keeps on repeating. Okay. So, I have either a 0 or a 1, then I have a 1, and this keeps on repeating. So, this enforces that at every odd position, because this is odd, this is even, and this is odd, I will have a 1, and the length is always odd. Okay. So, I will stop here today. Thank you.